The Big One Theory, Part 2. How the number one is used when simplifying fractions, aka reducing fractions, aka writing fractions in lowest form. In this video, I will review what the Big One Theory is, and I will describe how you use the Big One Theory to simplify fractions, and it's all based on the multiplicative identity. On a side note, what do you call it? Is it simplifying? Is it reducing? Is it putting fractions in lowest terms or lowest form? I've seen all of those on different resources that I use to help students practice fractions. So what do you call it, and why do you call it that? Well, I look at simplifying fractions as looking at the fewest number of pieces used. Reducing fractions means you're reducing the numerator and the denominator, but not the amount. That's the one that gets a lot of people the most confused, is when you say it's reducing it, it makes it sound like you're actually changing the size of it or the amount of it, but you're actually not. And then you have lowest terms, which is just looking at the form of the fraction that is using the least number of pieces. And so in order for students to understand that, you really need to practice with them using physical pieces. So you start with the concrete, your fraction pieces. I liked the fraction circles way better than fraction bars, especially when you're introducing fractions, because you can tell when a circle is complete. A rectangle can be added onto and it still looks complete. So when I'm introducing fractions, I always use the fraction circles. And I teach how and why certain fractions are equal to each other using those fraction pieces. So first I would present the half size one. And then I would say, okay, everybody, use your fraction pieces to find how many different ways you can make something the exact same size as this using whatever pieces. And I said, it has to be exact. It can't hang over any. It has to be exact. And so they would go through and do that. And then we would do a chart, something like this. So I'd have them get out a piece of notebook paper, and I would have them write the fraction half, because we would be working with the half piece on the circles. And I'd have them write that in the corner of their paper. And then I'd say, okay, what's the next fewest number of pieces that you use? I said, was anybody able to make half using just 2 pieces? Oh, yes, me, I use these. And what are those called? And you figure out that they are 2/4. And then, did anybody use 3 pieces? Why, yes, I used 3. And what were those called? Those are 3/6. And you continue with 4/8, 5/10. My set went all the way to 12ths, so then it would be 6/12. And after that, it would be like, hey, we ran out of pieces. Does that mean there's nothing else equal to half? Or can somebody predict the next one of 7/14? And we would get into that discussion. Then I would have them look at those fractions. What do you notice about those fractions? Somebody would always raise their hand and say, well, look, the numerators go 1, 2, 3, 4, 5, 6, 7. And I said, well, look at the denominators. And they're like, oh, 2, 4, 6, 8, 10, 12, 14. I said, and where are those? Where have we seen those before? We always wrote multiplication facts onto a multiplication chart and timed them. It gets them really familiar with multiples and factors. And that did look very familiar to my students because we did that all the time. Well, once we did that, then I said, okay, well, what's the next biggest piece? After half, then you have 1/3. And I had them write that on the line below that. And do the same thing. Find all the pieces that are equivalent to 1/3. Well, they have 6ths, but none of my fraction sets had 9ths. So I would say, okay, well, let's think about this. If you have a 1 and a 2, you know the numerator is going to be 3. What would the denominator be? And I'd have them predict. And then, okay, we did have 12, so they would have 4/12. We did not have 15, so then we would use our prediction again to find 15ths. And then I would have them again examine those fractions. What do you see? Well, the numerators still go 1, 2, 3, 4, 5. And the denominators, that's not the 2's this time. What is it? It's the 3's. It's 3, 6, 9, 12, 15, so you can count by 3's. And then we did it again with 4ths, and 2/8, and 3/12, and 4/16, which we didn't have 16, so they had to predict that one. And they had to predict 5/20. And then again, you examine the fractions, and you notice that those are the 4's, 4, 8, 12, 16, 20. What do you suppose, looking at these fractions, what do you suppose simplifying or reducing or writing the fractions in lowest terms or lowest form would be? And we would have that discussion. And then we would look at, oh, it's all the ones that are on the left. that we wrote, 1/2, 1/3, 1/4. Those are equal to even the ones that are written with larger numbers like 5/10, 5/15, and 5/20. But they are simplified to lowest form or lowest terms, or they have been reduced, not in size. I actually didn't use that one very much. I was trained well. Thanks, Dr. K. But reduced is used in a lot of your resources and textbooks. So they do need to understand what it means in case they run across it later. But then I would do it again with non-unit fractions. So instead of 1/2, we would do 2/2 or 3/2. Improper fractions can be simplified also. And we would go down and we'd do the chart again with those, looking at the pieces and making equivalent sets of those pieces. That helps them understand what lowest terms mean. Now they're working with the fraction pieces and writing it in a chart, taking the concrete and putting it in the numeric form so they can see the connections. Building those connections is one of the most important parts about teaching fractions. Not moving on too fast, but allowing them to work in it and kind of wrestle with it for a little while and build their own understanding. And knowing their multiplication table makes this so much deeper. The kids are able to go a lot deeper in their understanding because they're not having to wrestle with their multiplication facts if they've already got them memorized. Memorizing those facts makes learning your fractions so much easier. And you can get much more in depth. Quick review of what the Big One theory is. I did do this in part 1 of this video, but we'll do a quick review. It's the idea that the number 1 comes in many different forms. In fraction forms, it's like 5/5. Numerator and denominator are the same. And you can use those forms to change parts of equations while preserving the value of that part of the equation. And the last thing, you can use it in getting common denominators, which was video 1, or like this video in simplifying fractions, and then also in solving equations and rationalizing denominators. And there are many other uses for it. And it all comes down to the multiplicative identity. Multiplying anything by 1 is itself, but also dividing anything by 1 is itself. Simplifying is basically dividing by 1 in the form of a fraction. So here was our multiplicative identity, because you're multiplying half by 1/1 and you get half. And you multiply half by 2/2 and you get 2/4. So 2/4 is equal to 1/2. Half divided by 1 is still half. You divide numerators and denominators just like before. This is the concept we use for simplifying the fractions. So if you look at the next example, 14 and 16 are both divisible by 2. So I made a 1 out of 2, putting it as 2/2. So we're going to divide by 2/2 and you get 7/8. Now, if you've worked with 7/8 on your chart writing before, which I would usually go all the way up to 9ths and 10ths on those paper writing exercises, and they would see that 14/16 is on the same row as the 7/8. So that is the whole idea behind using the Big One theory to simplify. Here's 3/9 as an example. So a lot of times I would hear people say, and this is how I was taught. I started teaching my students this way, and what I found is they couldn't figure out why you were doing it. But the teacher would say, oh, divide the top by 3 and divide the bottom by 3. But what I found is that seems a little bit disconnected to why are you doing that? Why are you dividing by 3? And why can you divide that by 3? And it's because when you divide the top and bottom by 3, what you're actually doing is dividing by 1 in the form of a 3/3. So have them write it like this instead, and it makes much more sense. Then you can divide straight across. And yes, you can divide fractions straight across. We'll get into why you multiply by the reciprocal when we take a look at dividing fractions, but you can divide straight across. 3 divided by 3 is 1, and 9 divided by 3 is 3. And thus 1/3 is the simplified version of 3/9. Let's try this one, which is using much bigger numbers. Sometimes it's difficult to know what those numbers are divisible by, so it's helpful to just simplify them in any way possible. I look at those two numbers, I see the 8 and the 6, and they're even. So we're going to divide by 1 in the form of a 2. So we're not going to divide the top and bottom by 2, but we're going to divide by 2 over 2, which is 1. You divide 108 by 2, and in this I would talk to them about mental division. You don't need to do long division for this. You split 108 into 108. What's 100 divided by 2? 50. What's 8 divided by 2? 4. So 108 divided by 2 is 54. Same thing with 126. Now you have numbers that are both on the multiplication chart which we have studied, 54 and 63. And if they've studied it enough, they should recognize that both of those numbers are on the 9s row. 63 and 54 both are divisible by 9. So we divide by 1 in the form of 9 over 9, and you get 6/7. So as you can see, the key to being able to do this well is knowing those multiplication facts. Make it memorable with practice. Cute sayings are helpful, songs are helpful, but make sure that your cute sayings and songs connect to your mathematics that are involved. The butterfly didn't connect to anything, and there were like 3 different times they used something called the butterfly, and it got mixed up in students' heads because it never connected the math of why they were doing what they were doing, other than they were just drawing a butterfly on their math, because that seems totally logical. It doesn't. It seems random, so therefore it's more difficult to remember. It's more difficult to understand. Repetition is a better way to practice and bring understanding. The more a student practices a skill over several days, not just one day, but over several days, and then repeats it a week, the next week, and the next week, just a little bit of repetition for practice. But the more they do that, the more they have to think about it, and the more they generate in their own mind their own understanding of what it is that you're studying. And that's what they need to do, is generate their own understanding, not just take your understanding and take it out of your mind and insert it into their head. That doesn't work. Each person thinks about things differently, so they have to learn how to think about things. And sitting and thinking about something and wrestling with it is a good thing. That's how you make it more memorable. Thanks for hanging out with me this fine, bright fall day. See you in class.